We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system, offering an unprecedented look at its swirling, enigmatic atmosphere. For generations, Neptune has captivated scientists and dreamers alike with its icy blue allure, its secrets cloaked behind vast distances and dim light. Thanks to relentless scientific effort and ingenuity, we're now on the brink of a remarkable breakthrough, the most detailed images ever taken of this remote, frigid giant. These new views allow us to peer into Neptune's stormy atmosphere, revealing surprising findings that are poised to reshape how humanity understands the solar system's outer frontier. In August 1977, Voyager 2 embarked on its historic journey, venturing into regions no spacecraft had ever explored. After a 12-year odyssey spanning billions of kilometers, it reached Neptune in 1989. As it approached this distant ice giant, Voyager 2 captured breathtaking images of a world bathed in bands of azure clouds and marked by astonishing atmospheric drama. Among Neptune's most striking features was a colossal storm that appeared as a vast, slate-colored disturbance, roiling with power across the planet's atmosphere. The spacecraft also revealed 4 faint rings encircling the planet and 6 previously unknown moons, deepening Neptune's mystique. Voyager 2's encounter with Neptune was brief, just a few precious hours out of a journey covering more than 7.1 billion kilometers, but it provided humanity with an unprecedented window onto the planet. The iconic image it captured, an intense blue globe marbled with towering white clouds and swirling storms, has defined Neptune in the popular imagination ever since. Yet even that famous hue, we now know, is somewhat misleading. Neptune's real color is a softer, greenish blue, a subtlety often lost in the grandeur of space exploration but critical to understanding its atmospheric chemistry. For those seeking more images of Neptune online, the scarcity is striking. Despite Voyager 2's daring flyby at just 4,950 kilometers above Neptune's cloud tops, an astonishing feat of navigation, the number of detailed photos remains limited. The reason lies in Neptune's vast distance, about 30 times farther from the Sun than Earth. That remoteness means it receives only a tiny fraction of the sunlight our planet enjoys, making photography in such dim conditions a profound technical challenge. When Voyager 2 finally arrived at Neptune, after a gravity-assisted slingshot past other outer planets, it was racing through space at a blistering 27 kilometers per second. This speed and darkness made capturing clear, unblurred photos a monumental task. Voyager 2's engineers had to use every ounce of ingenuity, deftly firing the spacecraft's thrusters to adjust its orientation while employing long-exposure techniques to gather enough precious photons. Thanks to these clever maneuvers, Voyager 2 managed to send back some of the clearest, most hauntingly beautiful images ever captured of Neptune. Just hours before its closest approach, it snapped incredibly detailed pictures revealing features never before seen: long, wispy, high-altitude clouds streaking across the planet's atmosphere. Unlike Earth's cirrus clouds made of water vapor, Neptune's are composed of frozen methane crystals, giving them a ghostly, otherworldly appearance. These formations stretch for thousands of kilometers along the equator, each cloud measuring between 50 and 200 kilometers wide. So high are they in Neptune's sky that they cast distinct shadows on the hazier layers lying 50 kilometers beneath them, a revelation that gave scientists their first ever glimpse of such cloud shadows on another planet. Even today, observations from the Hubble Space Telescope reveal how these clouds can form and dissipate in the blink of an eye, highlighting the dynamic, restless nature of Neptune's weather. When Voyager 2 captured these images, the planet was lashed by some of the fastest winds in the solar system, gusts exceeding 2,000 kilometers per hour. That's nearly 3 times faster than Jupiter's winds and almost 9 times swifter than Earth's fiercest hurricanes. Voyager 2 confirmed that Neptune is a world of truly extreme weather. Among its most iconic discoveries was the Great Dark Spot, a vast, oval-shaped cyclone akin to Jupiter's Great Red Spot but even more mysterious. Roughly the size of Earth itself, this immense storm had a dark, cloud-free center, a swirling maw of turbulent gases slicing through Neptune's atmosphere. Neptune, an ice giant roughly 4 times wider than Earth, boasts a radius of around 15,300 kilometers and a volume of about 15 trillion cubic miles, making it 58 times larger in volume than our planet. But unlike Earth, Neptune lacks a solid surface. Instead, its dense atmosphere of hydrogen, helium, and methane stretches deep into a slushy mantle of ammonia and methane ices that likely surround a small rocky core. Deep within, conditions grow wildly extreme. Despite its frigid name and icy exterior, scientists suspect Neptune might even host a superheated ocean buried beneath its dense layers, a tantalizing possibility given its average atmospheric temperature of -360 degrees Fahrenheit (-218 degrees Celsius), making it one of the coldest places in the solar system. How such an ocean might exist so far from the Sun is a question that continues to puzzle researchers. After all, sunlight takes over 4 hours to reach Neptune, arriving with barely 0.1% of the energy it delivers to Earth. One theory suggests internal heating from gravitational compression or interactions with its largest moon, Triton, might provide the necessary energy. However, not all scientists agree. Researchers like Sloan Viktorovich and Andrew Engel argue that the odds of such an ocean forming from internal heat alone are slim, estimating a probability of only about 15% at present. Even assuming Neptune continues cooling over time, their models suggest it would take 1 billion years for that probability to rise to 40%. Another idea proposes that Neptune's remarkable internal energy may be the legacy of a massive ancient collision. Neptune is unique among the planets for radiating nearly 3 times as much energy as it absorbs from the Sun. This excess heat might also help explain the planet's significant axial tilt of 28 degrees, which is remarkably similar to Earth's and leads to pronounced, if slow, seasonal variations. Each season on Neptune lasts roughly 40 Earth years, since a single Neptunian year spans an astonishing 165 Earth years. Meanwhile, a day on Neptune is a brief 16 hours, its rapid rotation driving the fastest winds in the solar system and contributing to its wildly turbulent atmosphere. The composition of Neptune's atmosphere is dominated by hydrogen, about 80%, and helium, about 19%, with methane making up around 1%. That methane, though a minor constituent by percentage, plays an outsized role in Neptune's appearance. It absorbs red light and reflects blue, giving Neptune its signature vivid hue, though the exact shade depends on atmospheric depth and conditions. This striking color, so memorable in Voyager 2's images, has fascinated astronomers for centuries. High-altitude methane ice clouds enhance that blueness by scattering sunlight, much like Earth's atmosphere produces its blue skies. Despite their similarities, Neptune and Uranus present strikingly different visual profiles. While Neptune dazzles with its deep azure tones, Uranus exhibits a paler, more muted blue-green color. Uranus's extreme axial tilt, its poles nearly aligned with its orbit, results in seasons lasting decades and long stretches of polar darkness that hinder the formation of the dramatic high-altitude methane clouds that enrich Neptune's color. Both planets share similar atmospheric compositions, including traces of ammonia and other gases that, combined with temperature, pressure, and complex circulation patterns, create dynamic, layered weather systems still not fully understood. Voyager 2's visit to Neptune remains one of the most ambitious and productive encounters in the history of space exploration. The images and data it returned continue to shape our understanding of the outer solar system, revealing Neptune as not just a distant, frozen ball of gas, but as a vibrant, active world of roiling storms, powerful winds, and dazzling, ephemeral cloud formations. It showed us methane ice clouds casting shadows on hazy atmospheric layers below, features once thought impossible to detect across such vast distances. It captured the great dark spot in haunting detail, a reminder that even in the coldest reaches of the Sun's domain, weather can rage with terrifying power. Today, decades after Voyager 2's brief flyby, our best images of Neptune still rely heavily on its legacy, though instruments like the Hubble Space Telescope continue to refine our view. Scientists remain captivated by Neptune's mysteries, from the question of hidden oceans to the mechanisms behind its extreme weather and internal heat. It stands as a testament to both the limits of our knowledge and the boundless promise of discovery. As humanity sets its sights on returning to Neptune with new probes and even more advanced technology, we carry with us the lessons of Voyager 2, that even the most distant, cold, and seemingly silent worlds can hold secrets capable of changing everything we know about our place in the cosmos. Yet despite all that Voyager 2 taught us, Neptune remains in many ways an unsolved puzzle, its mysteries layered beneath thousands of kilometers of turbulent atmosphere and veiled in an icy twilight where sunlight is but a dim ghost of its strength closer to home. Scientists have long dreamed of returning, not for a quick flyby, but for an extended, deliberate study, perhaps with orbiters, atmospheric probes, or even landers that might one day sink into the slushy depths to measure what lies hidden below. There's something uniquely alluring about Neptune's remoteness. Unlike Mars or the Moon, it is not a place we imagine colonizing anytime soon, but rather a frontier for pure discovery, where every question answered spawns a dozen more. Neptune is so distant that even messages from Earth take 4